Welcome to Brain Vision.
First, we use conservation of energy to find the speed of the ball as it reaches the bottom of the shaft. So we know that speed of the ball initially is mgy. That's the time when it starts to drop, and at the bottom of the shaft, this is equal to mv square, since there is no potential energy over here. This gives velocity to be equal to root over of 2gy, and we solve this and we find this velocity to be 49.5 meter per second. Now, since the ball is dropped, the direction of this velocity is downward, and we are given vector b. Let's write it over here. The direction of b is told to be towards waist. Now, using right hand rule, the direction of force is given by, so direction of force is equal to direction of v cross b, right? And by right hand rule, we take the cross product, and we see that if given q is less than 0 or q is negative, this vector f should be towards south. Now, we know that here, since q is 4 times 10 to the power 8 times the charge of the electron, which is negative, force should point towards south. So this is, let's write, this is q times v cross b, because it also depends on the sign of q. So yeah. Now let's find the magnitude of force. So this is basically q times v cross b, as I wrote over here. This means that this is q times b sine theta, and theta is 90 degree here because these two are perpendicular, and sine 90 is just 1. So we solve this and we get this value of force to be 7.93 times 10 to the power minus 10 Newton. Now, while doing the calculation, make sure you write Q in terms of coulombs. So you have to multiply this factor with the charge on each electron, which is negative 1.6 times 10 to the power minus 19 coulomb. But don't worry about the sign here, because we have already considered that, and here we are just trying to find the magnitude.